like, I really don't want any of these things to be turned into this aspirational story of like, oh, quit your job and write an open source library. It's like, yes, you can do that, but there are a lot of circumstances that go into that.
How did the best machine learning practitioners get involved in the field? What challenges have they faced? What has helped them flourish? Let's ask them. Welcome to Learning from Machine Learning. I'm your host, Seth Levine. Hello and welcome to Learning from Machine Learning. On this episode, we have a very special guest, Ines Montani, the co-founder and CEO of Explosion, the company behind SpaCy, which is an open source library that every natural language processing practitioner should know. She's been the keynote speaker at many different Python and data science conferences around the world. Overall, just a rock star and inspiration in the field. Ines, thank you so much for joining me.
Yeah, thanks. Thanks for having me.
I'll start off with this. Did you ever expect to be the CEO of a software company like Explosion?
Nope. I had no idea what I was ever going to be. I think even when I was younger, I kind of had no real concept of what it would actually be like to have like a job. And yeah, definitely if you told me that this is what I'll be doing, I would have been very confused.
So what initially attracted you to computer science, machine learning, Explosion, all of this?
Yeah, I think it's kind of, the combination of computers and in my case, especially language and teaching computers about language. So I've always programmed. I started out as a teenager on the internet, making websites. Like I found out that Microsoft Word let you make websites and then you could put these on the internet. And there was some like web space included with our internet contract. And so I uploaded a website that was super exciting. And there was this whole online community of girls making websites, doing design that I was super active in. So I was mostly like an indoor teenager. That was my main hobby. So I didn't actually then go into computer science. I don't really have the classical tech background because I don't know, at the time, I didn't really see myself as a programmer. Like the only frame of reference I had was like, I don't know, the guys in, computer class. And I really didn't see myself as part of that. So I did communication science, media science, and linguistics because language was also something I was always into. I did Latin in school for like a really long time because people told me like, hey, it's going to help you when you learn languages later on, which then I never really did. I just stayed with English and Latin till the bitter end. So I didn't have to do, I think, chemistry or physics. I preferred Latin. And so that's kind of, that's kind of my background. And then in NLP, I found a way to really combine all of the stuff I'm passionate about and, really making something useful for people. And that's kind of how it started when I met my co-founder, Matt. He had just been writing SpaCy and was kind of, right in the middle of it. And I found that really exciting. I learned that actually computers don't learn grammar. It's all statistical, which made it even more interesting in some other way. And there was so much to innovate at the time. It was very early. Most software was really just written for research. And there was really this gap of, a piece of software tool that was really designed for practical use with visualizations, good documentation, and really, a practical design. And that's kind of what we ended up doing with SpaCy.
Very cool. That's really exciting. Two fun facts. When I was in college, I did engineering. And one of the reasons that I stuck with engineering was because I didn't need to take a language. I ended up taking more computer languages, which, sort of count. And back, I don't even remember when, I guess starting middle school, you have to choose a language in the education system. So they would say Spanish, French, or Latin. I definitely did not sign up for Latin. And my teacher pulled me over to the side and was like, I think it would be a good idea if you take Latin.
Yeah, it's kind of a special type of person. Like, I think there is something nerdy to Latin as well, like who, yeah, did Latin for a very long time.
Yeah, absolutely. I think, well, it helps you sort of break down words. It helps you, understand, yeah, I guess where some of the words come from. And then I found there was just like a lot of memorization when I was doing Latin.
Yeah. Yeah, we would pretend to speak Latin to each other and like mess with the other kids who were doing French and like didn't get it and really thought we actually learned to speak Latin in Latin class.
Yes. It gives you the occasional Roman saying that you could throw around. But yeah, a dead language, they say. No one's speaking it today, but it is the basics for a lot of the Romance languages, which is very nice. In the position that you were in, you were able to sort of, when you were probably developing websites back, when you were younger, it was like HTML and CSS. That's what it was for me. And then we've seen sort of the evolution of the web into what it is today, which is using JavaScript frameworks and all of these things, where a lot of the control for some of the aspects are maybe you're kind of giving it up for some of, like, things are more automated, if you know what I mean. But if you could speak a little bit to the changes that you've seen in web development. Yeah.
I mean, back in the day, it was definitely, you could just look at the source code and, really see how everything works. And that's kind of, not something you easily get these days. And, there is a lot more complexity around it, but it also is solving more problems. Like, we kind of come full circle with like static site generation. Like, our sites became so complex and slow, and that we now generate them statically. And it kind of reminds me of, back in the day, I had this blog software called Gray Matter. I don't know if anyone remembers this. Maybe people who listen to this do. And it basically a CGI script that would then generate static sites. So it was like a super old school static site generator. And it's kind of, I also use the static site generator now for my website, but It's all very different. But actually, I think what you could really see a lot of parallels between like the journey of the web and how things have developed there and machine learning, because it's the same considerations about like lowering the floor versus raising the ceiling. It's like easier than ever to start a website. Like, your grandma can just do it using Squarespace or whatever else there is, and that makes it really easy to get started. But at the same time, there's a huge demand for web developers, and there's constantly new developments. The technology is changing, even browsers and all of that. So just because it's easy to make a website now doesn't mean web developers are obsolete. And similarly, just because it's easier and easier to do machine learning now doesn't mean we don't need machine learning developers anymore, or developers in general. If anything, we need more of them because there's just so much more to do.
Absolutely. I can definitely relate to that. Seeing, the current status of machine learning, and people are pushing, AutoML, and it's easy to create a model. You know what I mean?
Yeah.
It's hard to get it into production, but if you're using, well, I should say harder, but if you're using something like AutoML and everything goes smoothly, then you're all set, right? But if once you run into a problem, and you will eventually run into a problem because context changes, right? The uses of a model change over time. That's when you really need machine learning practitioners who have a deep understanding of the field and what's going on. You need to
and also what they're doing, like with machine learning, because often you don't just do machine learning for the sake of machine learning. There's like a deeper thing you want to solve, and then it's like the hard part is in trying to breaking down that business problem into something you can actually solve, and really understanding the domain. Or like, yes, we all really want to neatly put the world into categories, but it just doesn't work like that. So I feel like, by the time you get to the point where you just have to press train, most of the, hard parts are already done.
Right. the heavy lifting is done when you're up to the training part, right? Because, well, you assume that you already have your data set.
Yeah.
But
yeah. And then like nothing, nothing works, and your model isn't learning. And then you have to kind of, go back and figure out why.
Yeah. Or the scariest thing, you get very high performance metrics, like too high.
Yeah. It's like our 99% accuracy. You're like, shit, something's broken. That's
something,
not. Yeah. Or it's like, hey, if your evaluation is shit, like, cool. Yeah. You can always get like really good results. Yeah.
Yeah, absolutely. So, speaking of, solving a business problem and applying natural language processing to, businesses, that's, SpaCy and Explosion written all over it. Me personally, I've used SpaCy when I was really getting into natural language processing, say 4 or 5 years ago. I was watching one of your videos. And I was using DisplaCy, which is one of my favorite tools still. I think it's still incredible.
Yeah, I had a lot of fun building that, and
being able to visualize what you're doing. The nice thing about it was that it was easy to explain it to other stakeholders, which was really cool, because there's so much that we do in machine learning. It's kind of hard to explain it to other people, but I think that tool and other things in the SpaCy universe, like, you can sort of bring people in better. I think Prodigy, even though I guess it's really created for developers, if you want to be labeling different things, you can show them, you can show them the process of how it's done. I remember vividly the first time that I showed DisplaCy with named entity recognition to somebody who is doing media and things like that. His jaw dropped. He's like, this is exactly what I want to do. We need to be extracting all of this information. So in a way, I guess, thank you.
It's so nice. Like, it's always, of course, I know that, like, hey, people are using our software and I think they find it valuable, but it always kind of hits differently. Like, to actually talk to someone who's like, oh, using your software. And I'm like, oh my God, you use my code. That's so cool. And also, if you do open source, like, a lot of what you see is mostly on, on the issue tracker when people have problems, and nobody goes on the issue tracker and just says like, hey, everything worked, I have no problem. Like, that's the point. It also clogs up an issue tracker. I'm not saying people should be doing this, but of course that means, you only get like, some sort of view of what people find difficult. And so it's really nice to hear from people who are like, yeah, it worked.
Yeah. There's a new feature for GitHub. There should be a new one, right, where you can give some claps or some positive feedback for the amazing work that people are doing in open source. And when you think about a library like SpaCy, so there wasn't really like that many libraries that were out there that you could really use for production. I mean, I'm not even gonna get started on NLTK. Like, I mean,
it just had a very different purpose. Like, this was a good example of a library that was, designed for research, teaching. You have a lot of different implementations and algorithms, and it's kind of just a very different focus. But SpaCy very consciously kind of went the other way and took a very opinionated approach.
Yeah, which is great for real world. So I've been able to use SpaCy for everything from tokenization and lemmatization, breaking things down by sentences with the beautiful name Synthesizer.
We always have a lot of fun naming our components.
Yes. No stemming, which I like that, actually. And all of the amazing new things that you guys have developed over the years. I mean, SpanCat is incredible. And now with SpaCy LLM, it's really just amazing to be able to have a pipeline that you can depend on, that you can extract information that you need, that you can, process text, any type of text in a way where you can extract meaningful information from it. So it's been very valuable for the work that we do at my company and the work that I do. Yeah,
that's
it's
nice to
great.
hear. But yeah, I mean, the pipeline approach, I do think that's something, that kind of makes SpaCy special, that SpaCy has always focused on. And this idea of like, hey, often what you're trying to do is a series of steps that you want to apply in order. And these steps can be powered by pretty much anything. You might have something really simple and rule-based from good old regular expressions, or SpaCy's token rules, where you can really match on different predictions by a model. Or, you might want to have like a regular deep learning model powering the component, or nowadays also a large language model by a SpaCy LLM that basically behaves exactly like the regular named entity recognizer and lets you get started quickly. And it really kind of solves that problem of getting to a prototype stage. Because before that, hey, it still needed like, serious annotation effort to get to something that might not even work, that you can improve. And so mixing and matching these different components and techniques, I think, is really important for practical use cases, because a lot of them don't very neatly, turn into like an end-to-end prediction problem that you can just solve. It's often, always a combination, including like really specific business logic. And we think that that's where the pipeline can really shine.
Absolutely. I mean, like you were saying before, it always stems from the business understanding and understanding like what problem are you trying to solve. I think, and we'll get into it later, but like people are distracted a bit by like the shiny new object, right? But when it comes down to solving problems, heuristics and regular expressions and rules, they might not, solve everything, and they might not be the most sophisticated and the newest thing out there, but it'll give you a really good start. And having that as part of your system is or just
really the baseline. Like you want to have, you want to know what you have to beat. Like, yes, you can train a fancy machine learning model, but if it doesn't perform better than some like dictionary lookups, then what are you really doing? And I think also the ability to teach by example and supervised learning, people often see the need for annotated examples as this obstacle that like, oh, we need to avoid at all costs, when actually for a lot of use cases, especially practical ones where exactly what you want the computer to do, it's like an opportunity. Like we have this new way of showing the computer what we want it to do by showing it examples where we know the answer. And that's like really cool, and that's really effective for a lot of ways. If you if you have a good feeling for how to create these examples, this is still for a lot of use cases like the absolute best, most straightforward way to get something done.
Yeah, absolutely. I think sometimes people want to find like a trick, like some trick to do it. I don't know, like use unsupervised learning or something but like just spend a week labeling data sometimes, and then you can do a really good job of creating a model, at least like get the data and then use basic methods, get your baseline and see where you're at. A scikit-learn, support vector machine, or one of the simpler, more traditional models, has its own pipeline which you can get into production much faster. And you don't have to be reliant on either an extremely large model, which has its own trade-offs, or an API call, which, you kind of want to reduce any API calls.
And also if you're really only interested in like a really small specific thing, not even small, but like a specific thing, there's like so much that you don't need of like a really massive model. And so I think the trick here is to see, hey, how can we kind of combine the best of both worlds and take what's there in these very large models and their representation and what they know about the world and the language, and use that to then train a model that's more specific, that knows a lot more about what you're trying to do, and a bit less about the language and the world.
Yeah, absolutely. So having, someone who's, co-founder of SpaCy, and now, SpaCy version 3 was released, say, about 2 years ago. How have the goals, if the goals have changed, or how's the design changed? How have you seen like the expansion and evolution of SpaCy?
Yeah, so I would say we've actually always really stayed true to our main goals, which is provide this opinionated approach and like the best implementation of a given component that's like optimized for real world usage. So it needs to be accurate enough, it needs to be fast enough, it needs to run on all kinds of Python versions and platforms, and just have a unified API that's like easy to program and work with. So that's always been the core philosophy, and we've kind of kept that up over the evolution of machine learning, like from linear models that were like super fast to deep learning, different types of model implementations, and now also large language models, where you kind of have to do the same work in a way. Like you have to look at what's there in research, what works, how can we improve these methods. And before we did that for model implementations, and now we're doing that for prompts, and really optimize those for information extraction, and like what do we need to do named entity recognition. Because even though, if you just scroll through your LinkedIn feed, you might think like, oh, NLP is solved. Like there are actually a lot of things that even we haven't quite figured out how to get that information out of even the largest large language models. So that's kind of always been what we've been doing. But of course, library has also changed over the years. Like we've improved a lot of things. We also implemented new components that kind of address different needs people have. Like people really want to extract spans from text, and like arbitrary spans, and a named entity recognizer that's like designed to be really sensitive to boundaries just isn't the right fit for that, because it works so well because it's so sensitive to boundaries, which is great for person names, but not for arbitrary spans. So we built the span cat component. We also worked on other things like co-reference resolution, which actually solved a lot of problems in extracting relations from text. Like you want to know which pronouns refer to like which person, and create these clusters of like, this is kind of the same person or object. So stuff like that. And I think also with like the growing complexity of machine learning, like one trade-off, or one challenge we've always faced is like, on the one hand, we wanted to be really easy to get started and have defaults that make sense out of the box. And actually, if you want to do NER, you shouldn't have to think about the model implementation and what to choose. It's just like, it should just work out of the box. But the library also needs to grow with you as your needs get more specific and you want to do more sophisticated things. And so we want everything to be customizable and like powerful. And it doesn't it doesn't just mean simple. Like it also needs to have this extensibility. And in SpaCy 3, we introduced the config files that really save all defaults and all settings for a model, and that you can kind of exchange with your team and really make sure you run reproducible training runs, and also the project system. That's also actually something that's very popular. Whenever even we talk to companies or introduce them to it, it really like changes the workflow to have like a project structure, to have like a file that kind of works a bit like a make file, and really have orchestrate all the different steps that need to happen as part of a project, because that's also part of it. It's not just the machine learning model, it's also the whole workflow around it, basically.
Right. That makes a lot of sense. When you're a data scientist, machine learning engineer, whatever you want to call it, software engineering best practices are so important. And seeing a library like SpaCy, where it's clearly like thought about, how these things are going to be done, and you could read it, you can understand it, you're able to modify it. And I guess it's a library that's meant for developers, in a lot of, I guess all libraries are, but it's like, it's really thought about, made for developers, so you can take this pipeline and you can do so many things with it. I mentioned some of the use cases before, but I'm also thinking how I've done like language detection, using SpaCy and, the space,
like a plugin,
the SpaCy universe, something in the SpaCy universe.
Yeah.
I have to get more into those config files. I applied it to one of my more recent projects. like outside of SpaCy, but yeah, SpaCy's config files. That's something that I'm writing down.
We also have we released that config system as like a separate library called Confection. So
okay.
that was basically, we had it in SpaCy before and people liked the concept. And so we were like, hey, how can we make this available as a more general purpose tool? So even if you want to use it for other projects. And the nice thing about it is that it doesn't only have like values in kind of Python's config parser format, you can also refer to registered functions. And so you can really build up this tree of objects like, hey, here's this object that needs to be passed into that function as an argument, and you can define all of it. It uses Pydantic under the hood for validation and, type checking. We have a VS Code plugin for SpaCy config files, so you can actually hover over like a variable or registered function and it tells you what it is. So there's a lot of cool stuff you can do with modern Python. And I think especially these improvements to the developer experience that close the gap between prototyping and production are really important. Like, you don't want to have this workflow where, it's fine to work in notebooks and experiment, but like if you have this really rough prototyping workflow and then someone needs to take that and translate it for production, that really holds teams back. And so if you can have a workflow that works for prototyping and that you can also ship to production, that's like a huge win.
Yeah, that's the dream. And I mean, it's so tough, I think, because in machine learning, it's like in the data science, in the feasibility and exploration phase and tinkering phase of a project, like you need to have all of this flexibility. And then experimentation is obviously very important, trying out different parameters. But then when you finally are settled on something, things can be a little bit more narrow, and you have to get it, into production. It needs to work, every time.
And it's like, it sucks if you then find out, oh, it doesn't actually, work on those types of machines, or it doesn't, it doesn't perform. It's not fast enough. And then it's like, that's hard to fix if, you started off like not caring about this at all.
Right. You run into some bug, or I call it Python dependency hell.
Yes, oh God. Yeah, that's also, we're doing like, there is a lot of thought like that goes into that as well at our end. Like we have a lot of the libraries we depend on our own. So we implement, like we have this library that handles serialization because we often ended up being like, I don't know, ending up with broken SpaCy installations because of some dependency. And then there's some things we don't like. So we're like, okay, let's like vendor some of these great open source tools. Maybe also take those that aren't maintained anymore and update them a bit and really control our own dependencies to prevent as much as possible that like people end up in these weird, dependency hell scenarios, because that really sucks.
So what's next for SpaCy and Explosion? How are you thinking about, I guess, where you are now, and what expansions there would be?
Yeah, so we definitely have some component in mind for SpaCy that we want to develop for more, practical tasks, like around relation extraction. And also there are a lot of, semantic things. Like there's a lot of semantic role labeling, for example. There's like a lot of that stuff that's actually really, really useful and addresses a lot of the problems people have. But it's also, some of them are tricky to develop because, we need good benchmark data sets, and a lot of the stuff that comes out of academia isn't especially useful if you really want to find out, hey, does this solve real problems? So that's also why we like working together with companies occasionally and doing some of these consulting pipeline development projects, because we get to see what people are actually doing, and we also get to use our own library, which is really important because we have this whole document that we call I think collateral contributions that came out of, say, consulting projects where, I don't know, you build something, you're like, why is this so shit? And who wrote this? And it's like, oh, me. Yeah, okay, we should fix that. And there's a lot of these things you really only realize when you use the library yourself. So there's definitely kind of components. There's also a lot more work around like large language models and really, how to go beyond just like, hey, using an LLM as a like dialogue system, or, you know, kind of that as the last step. Like if you can have like this large language model that's surprisingly good at stuff, then we can also distill that down into something smaller, better, faster, private. And, you know, yes, that takes some work, but there are use cases where this is absolutely worth it. And so, yeah, we kind of trying to take it like one step further and not just stop at like, oh, yeah, LLM is like decent given it wasn't trained for it, and it's, yeah, kind of cheap via an API. So that's like, yeah, that's not good enough. And those are the use cases we're really interested in.
Yeah. LLMs, they're kind of just like pretty good at everything.
Yeah.
You know? But
Yeah. And I think a lot of these workflows are workflows of training task-specific models that I described, of like, hey, using an LLM to label some data to then train, you know, a smaller, you know, BERT-based model from those examples that really just targets that one specific thing, and is better, faster, more accurate, and so on. Like those are tricks that like people are using, but it's still pretty difficult for people who are just getting started. Like it is easy to just, you know, use ChatGPT, but we're really trying to basically make these workflows, these more advanced workflows, more accessible to people who maybe don't come in with this like deep machine learning expertise. And that's actually also where Prodigy and Prodigy Teams fits in. So Prodigy Teams, we just started our private beta, and that's really a SaaS product that takes SpaCy and Prodigy into the cloud and enables these types of workflows, because nice. You know, you want to experiment together, you want to take start with the prototype, collect some data, train models, try out different things, evaluate, and also label data with the help of all kinds of different automations, from models to rules, and do that collaboratively in a team with different people and kind of have this shared state. And that's really where Prodigy Teams fits in, and also providing the data privacy, which is, a big part of our, or core of our stack, that, hey, you can run it yourself, and it will have this cluster component that you can run in your own cloud. So no data has to ever, go to our servers. And and also I believe it shouldn't. Like a lot of, many of our users are working in finance, medical, insurance, lots of sensitive use cases where, you can't just send that data to an API or upload it to some random startup's cloud. And we think that's fine. And so we built an architecture that supports that.
Very cool. So that's, it's similar to what you were saying before, designing solutions for, many different companies. And then what I found, the startup that I'm at, we are trying to develop systems that can work for many different companies who are in different industries, with different contexts, with different corpuses of data, with different terminology that's being used. But sort of creating this system that can be used for anyone. So it's like creating this generalized thing that can be applied to particular companies. So it sounds like a solution like that, where you can combine SpaCy and Prodigy. That's a system. Other
things, because you're hosting this cluster, you could run Python on it. It's automatically turned into a form in the web UI. So you kind of have all the advantages of like a SaaS product, but still have retained that scriptability. And exactly. I think it's also important to meet companies where they are. And that's also something we've always wanted to do. Like even, they are like super hot visionary ideas, and a lot of those are cool. And we also have some of those, but I think, it's also important to build something that can be useful for people right now and help them in the transition into maybe some other technology, instead of saying like, oh, here we built something completely different that, you all should adopt now, which, really isn't, what fits into people's workflows. Or it's like how we call it, like, it's fine. We do sometimes reinvent the wheel, but like, you shouldn't reinvent the whole road and kind of try to own own the whole thing. And that's kind of how we see it. I think, it's fine to reinvent the wheel.
Right.
sometimes.
Sometimes. It's funny that you say that. I was just talking about that with someone, but you mentioned and you've spoken about some really interesting things about creating a software startup. So you gave a keynote. I know it was probably now 4 or 5 years ago.
5 years ago.
that I that I loved, that I love. I listened to it again. How to ignore most startup advice and build a decent software business. What a title for a talk. Now, 5 years later, can we revisit some of the misconceptions, or how you still feel about the misconceptions about running a startup?
Yeah, I mean, I think it's kind of, these ideas from that talk are, really kind of the DNA, of our company. And a lot of that has also carried through, even though, we've grown in between, and then, the team's changed. We are working on a SaaS product. So we did take some venture funding for, that product, and there are, pros and cons of that. But I still think, for example, one move we made very early on in the company is to say, hey, let's release a paid product, kind of as this transition from, SpaCy, which is fully open source, to, something that's more of a premium thing, and, get some revenue from that and see like, hey, does this work? Is this viable? Can this be, sustainable? And that's because, yeah, again, when we're starting out, we're like, yes, there are reasons you might need to run at a loss, and, make sense if you need upfront capital, but it doesn't have to be the status quo. You can also do stuff that makes sense, create value, and people will pay for that. And companies like open source, not because it's free, it's because it's open and you can work with it and script with it. And that's what it's about. And there are definitely ways in which, we've done a lot of things very differently from, your typical startup. We're like, we're also quite reasonable. We often, I think we're seen as, in general, if you, on the scale of startups, we're like, we may be a bit too reasonable sometimes and not visionary enough, but, we also want to do a thing that makes sense. And that's important. And especially at the moment, we're also looking at more ways to really make our open source development more sustainable and really, self-funded, because it's like, we don't want to have that dependent on a venture outcome. That's not great. And there are ways this can be done. So that's something, we're exploring.
Yeah. The business model of startups, there's a tendency, I would say a couple of years ago, where it was all about growth, right?
Yeah.
Growth. And that comes at the trade-off of sustainability, right? And that's something that that you're mentioning. And sustainability, working for sustainability, is a business model that will work in any climate, right? In any economic climate, whether VC is hot or VC funding is cold, whether the economy is hot or the economy is cold, which I guess is sort of related. But you can't go wrong.
Yeah. Or what the current trends are. Like they are, that's also something where it's like, in a way, yes, if you raise funding, you always sort of, dependent on what, whether VCs like you or what they're into the moment. But it's also, there have been periods where it's like, oh, this is kind of the new hot trend and that's what you should be doing. And we never wanted to be in a position where we really have to, completely change what we're doing and pivot all the time to, meet whatever, people find attractive at the moment. Like we want to do what makes sense for like our customers and users. And that's, And I think also there's so much value that can easily be destroyed if you really go down that narrow path where it's like either big or bust, and where there's kind of no in between or way out to say, okay, even if you have to, downsize and, you can be profitable again in some ways. And it's not like, oh, you didn't bet everything on like your growth. And then if it fails, then, well, that's like all this value that you've created is like just gone.
Right.
And we've always found that, frustrating and like counterproductive. And especially if you do open source. which, is creating so much value and is supposed to like, kind of be the opposite of that.
Yeah, I think it's an interesting, concept where Explosion, it appears, it seems, I mean, it does, it had a clear, pretty clear vision, right, to bring NLP to industry, and to bring in investors would almost create an unnecessary pressure. I mean, I know that you did a small raise, which, you do what you got to do to build in a way that you're comfortable with. But yeah, investors, taking major equity stake in your company, your goals start to change a little bit. You're thinking about, what am I going to do to get to the next fundraising round, as opposed to what am I going to do to provide value for my for my users, which, SpaCy and Explosion clearly keeps that in mind.
Yeah.
Which,
I mean, look, at the same time, it's like, okay, if you go for like the venture path, like, what you are building is a very large company and you are kind of aiming at that sort of outcome, which I still think, hey, if you're in developer tools, if you're in enterprise tools, that's totally realistic. You can, there's a lot of money that you can make if you build things that are valuable and good. So it's like, yes, that is kind of, a side of things. And, you can, I guess you do have to deliver something. And for example, right, like right now we're right before launching our next product. And, this is not, we can't really raise at the moment. And that like, that sucks. And that's, a problem, because we need to, get the product out and make sure we can keep the rest of our work sustainable. And, there is kind of a dependency there that's like, not always ideal. But at the same time, we also, we have customers, we have users, we have revenue, and we have like, a lot of what we have is open source, and we have products, we have like things there. Yeah. And we do have graphs that go kind of up like this as well. But there are other graphs that are like, maybe not like woo growth, and that's that's fine. We know we're doing something useful, and that's that's also at least important.
Yeah, I mean, I think it's about finding that healthy balance, right, between velocity and growth and sustainability. There's a really interesting point that you make in that talk, where you talk about, well, the team that you had building sort of a software engineering team, and you mentioned something called T-shaped and tree-shaped, and people or employees, skill sets. Yes. Yeah. Can you talk about T-shaped versus tree-shaped and how it applies? Yeah.
So I think T-shaped, I mean, I think that is kind of a common phrase to represent like, our skills, where you have this like strong base in the middle, and then kind of, these two other things that you're like less strong at, but that you also have, and that's kind of, that is desirable for many roles. But I've always found this metaphor to be like it's too static, and it's also, it doesn't really represent skills very well. So I like to think of it more as like, this tree, and you have a solid base, and then they're like all these little branches. And, they can also grow, like you can grow a new branch if you have to branch out into some other area. And branches can overlap. Like if you think of your team as like this little forest, like you can have like some trees overlapping, and maybe then, you have a tree that's a bit, covers some areas that the other trees don't cover. And, maybe it's also something I identify with, because that is how I see, myself and my background. Like, I feel like I kind of had to create a job or role for myself, because I don't really fit neatly into many of the traditional software engineering, whatever roles. There's just like all kinds of different things I can do, and somehow I make that fit together. And actually, similarly, my co-founder Matt, like in the beginning, we really did most of the work. It was just us for quite a while, and we were able to build like the a prototype or MVP of Prodigy, just the two of us, because together we had like everything needed.
Right.
for that. And that is an advantage you can have in a small team. And we kind of try to keep that up as we've grown the team. But it's also, people will argue like, hey, that's not very scalable. And that is, true. You can't even just, scaling like workflows where you have like two people who happen to have these very complementary skill sets working together. Trying to replicate that with more people is really hard. And that's also something, we found hard. And it's not because like, oh, we're so amazing or something. It's more about like, okay, there is, there's this very specific combination and like, combination of instincts that we had that worked. And then how do you, replicate that with other trees?
Right. It sounds like a really special relationship where you're able to complement each other, and then the whole is greater than the sum of its parts. And speaking about like that forest metaphor, that's what I've been thinking about. Like, the teams that I've worked with, how we're not just these static entities, right?
Yeah.
We are these things that are growing through time, changing. Our skill sets changing, our context is changing, so many of these things. And then I think about like the trees, the intertwining, right? And like you're able to like create this incredible thing. And you also bring up, this, it's sort of like a mindset also, where it's not static. You have this growth mindset. Skills aren't fixed. Skills, you're able to improve them over time. And I think that's what has helped me think about hiring and building a data science team, is finding, people that are able to do that, right? If you can find problem solvers, if you can find people that like don't necessarily like fit into a particular box, and I can relate to that also. Like what you were saying, like there's many things, right, that I can do, and I think it's important for a startup also, where for me, I started out as the data scientist, so like anything numbers, was go to me. And it's like, okay. It's not just like anything, right? But
then you also did design, right?
Yeah, that's true.
Yeah.
I did lots of graphic design and web design. So like something funny, we have these emojis as part of our product, and we wanted like a holiday special. So somehow it was me. I was the data scientist that was creating these holiday special emojis that then went into production, and whatever hundreds of users saw. But it's nice to be able to think about things from different perspectives. I think that gives you a really, it's the healthy way of doing projects, and you can kind of zoom in and zoom out and do different types of things. So where to go from here? I mean, we've talked about so many things. Let's talk about here's a good one. What's like instead of not most, but one of the most innovative ways that you've seen SpaCy use, or unexpected ways that you've seen SpaCy use? They could be the same, they could be different.
Yeah, I mean, there's so many, like, it's actually also, it's a question I get asked, like, sometimes, and it's like, oh, I don't always have like all the like super mind-blowing like use case, like, there's really a lot in like small details. But if I think about it, also, machine learning more general, like it also comes up a lot with like Prodigy. We had people working with like horses or cows in a barn, and all these everyday life things where you're like, oh wow, yeah, okay, sure, yes, you can detect, is the cow sick or something like that, and that's like, oh, that's important. Or these general machine learning use cases of I don't know, trying to predict how many meals you need on given flight to reduce food waste. And I find these types of things super interesting, and there are a lot of them also in NLP recommendation systems, where like just getting the model like 1% more accurate or 0.5% more accurate really translates to like millions and good, like really significant impact. Or also what I really like is stuff in journalism or investigative journalism. Like there's a like years and years ago, I don't know if you remember the net neutrality debate, I think in the US, and then it turned out that like all these like letters that were supposedly written in the name of like dead people or people who never sent these letters, like, being like, advocating, against
Right.
like, freedom on the internet, basically. And there was a data scientist who actually, I think, used like back in the day, it was mostly word vectors, I think also using SpaCy, and was able to prove that like, oh, these letters are all like fake and they're very similar and they're like automatically generated. And on top of that, also these people don't exist or, are dead. And that really like an investigative case where like, hey, the technology was used to really, show something or uncover something important. And I think also, there are probably a lot of use cases I don't know about in like a lot of these leaks, and all of these data amounts are getting bigger and bigger, and there is a lot in there, and it's way more than a person can read. So I think using NLP there is, pretty exciting and very important. So,
yeah, absolutely. Being able to, I mean, that's the power of natural language processing, right? Being able to take like endless amounts of data. I mean, these models now are reading more data, more text than anyone could in like, what do they say, like 40 lifetimes or, some ridiculous statistic like that.
But that's also why models, the text and everything, text grows faster than like computers get more efficient. There was even really motivated, like even SpaCy and like a lot of my co-founder Matt's like philosophy, like to program or like programming, and how he started writing his code. Like when he was still doing his PhD, it was kind of his advisor had this idea that like, well, the internet grows faster, like text grows much faster. Like we can't just sit around and wait for computers to get more efficient. We need to be smarter than that. And that's kind of how Matt randomly became known for writing like super fast and efficient software from being a linguist.
Right. I'm sure it's even greater now, but I know a couple of years ago I don't know, many statistics are made up, but they said, the amount of data that was created in the last 2 years is greater than the amount of data that was created in the last 100 years before it. Like some ridiculous statistic like that, which just shows how important, this type of work is. A more philosophical question, if you don't mind. Maybe. What do you view as the difference between natural language processing and natural language understanding?
I mean, it's one of these definition terminology questions, but like, I don't know, I guess I can try to approach it from a philosophical point of view rather than like, I don't know, I guess it's worth mentioning that like, that the terminology gets a bit vague, and like, previously stuff like text generation, that's generally seen as part of natural language processing, even though, intuitively you would think like processing is really a lot more predictive and information extraction, but that's also all under that umbrella now. And I'm sure, there are official definitions. So I don't want anyone to, listen and be like,
it's not meant to be a gotcha. It's not meant to be a gotcha.
Like, but no, I'm always trying to, even in talks I do and everything, I always try to optimize for the like, well, actually point that may or may not come up. But I do think natural language processing, it's kind of all the technology, all the different, techniques from information extraction, text generation, and so on. And, natural language understanding is more like, the goal of what, you're building, like natural language understanding pipelines, for example. You use, SpaCy uses natural language processing techniques to help you build natural language understanding pipelines.
Right.
I don't know if that makes sense.
No, that does. It does.
But I might be wrong. Like, it's, again, I'm just like, yes, I'm a person on a podcast, but I'm like just saying things.
Aren't we all? Right? Aren't we all? The point that I was going to make was, processing and understanding. Oh, this was it. Is that I love the companies, or like someone will say, no, that company, they don't do NLP, they do NLU. I'm like, like what? Like I never really understood that, right?
Yeah, but you kind of need to, I mean, I guess you need a P for the U.
Yeah, I wholeheartedly agree.
Yeah. Or I
And
guess the human can, maybe everything, in that sense, like if it's just a person, like we do natural language understanding all the time
that's
without
true.
doing natural language processing. So,
Yeah, I'm not, well, I don't even know, right? I think maybe we do have to sort of process it to in order to understand, you have to
yeah,
process.
what
But
does understanding mean?
there you go. How could we understand what
Do
understanding
we ever
means?
understand anything? Do we really
Yes.
understand? Yeah.
The only thing I know is that I know nothing, right?
That's like, yeah, full circle
Yes.
philosophy. Yeah.
Um, in the industry now, there's so much hype, right? Like what you were saying before, it appears on social media, like influencers, basically, that all the problems are solved
Yeah.
by large language models. I'm curious, from your perspective, how do you view the gap between the hype, that's the frenzy that's been going on? I would say since like the launch of ChatGPT, but now GPT-4 has been out for months, and the reality of machine learning and AI.
Yeah. I mean, there are different ways either to look at it. Of course, you have like, a lot of, new experts that, I don't know, previously were experts in the metaverse, and before that experts in blockchain, and, now they're like large language model experts. And that's like, it's
Beware.
whole other category. So it's like, yes, there is a lot of like, hype happening for like, very different motives. But of course, one thing that's kind of clear and different here is that it's really one of the first times that like, a really good version of the technology has been like so accessible even to, I don't even like say like not lay people, like people are not like developers and just, everyone has used ChatGPT and knows it, and, can actually experience like what a model can do, even though, just some, specific capacity or specific things for everyday life. And that is different from, a lot of other releases and, other discussions in the past. And there are also things that like, well, work surprisingly well. And it's like, really just making the thing bigger and bigger and bigger really, makes a difference. It's kind of one of these things. It's like, well, yeah, but like somebody just went and did, like OpenAI and others just went and did that, and we're like, oh, how about we make this like even bigger? And it's like, hey, that it works, and it's like, it's surprising, how well it works. But then, there's also the difference. There is this difference between like, well, what do you want to do with it? Like, you can make it generate stuff, but then there are a lot of, if you look at what's actually done in NLP or today in companies, enterprise, what's in production. Like, again, I don't have any stats, but I would say like information extraction systems are probably, the majority of what's in production today, also because that's the stuff that has been working pretty reliably for quite a while now. So, and actually a lot of these things are also things that companies were doing way before machine learning, and even way before like computers in some cases. Like there's just like stuff and text, and someone needs to go and like order that somehow with all kinds of different objectives. And people would write index cards and like punch cards and did all kinds of stuff, and then did stuff manually. And now there's more you can automate, or helping humans perform tasks. Like it's not just all automation. It's like an analyst would previously make more mistakes and it'd be less efficient, and now they can use suggestions and work faster, stuff like that. And I think these are just a lot of the fundamental problems. And I don't think this is all, everyone's now just going to stop what they're doing and replace that with like, a large language model. Like that doesn't really, that's not really, in my opinion, the path, like a reasonable path. It's just that like, hey, we have more tools now to actually solve these problems even better, but the problems remain the problems. And there is definitely still quite a gap if you're looking at the predictive tasks, like going from this from a generative model, or like a model that's trained with in-context learning. So really, that's kind of the distinction I want to make, because people now call BERT an LLM, and it's like, it makes the discussion really, and it is an LLM maybe, but it makes it really difficult.
It's murky. It's a little murky. What people are referring to as it, yes.
Yeah, and it's like, oh, by that definition, well, then we've all had LLMs in production for years. Is that what's new? But basically, in-context learning and transfer learning.
Right.
And, if you look at, the performance of a generative model, where then you kind of have to find the right output, parse it, and try to really make it do like a predictive task, named entity recognition, text classification, anything structured. The models there's still a lot of room for improvements. And, like the newest large language models don't perform as well as, maybe some of the hype would suggest. So we've done some experiments, like for a recent talk I did on the topic, where we just basically took some data sets, benchmark data sets from research for different text classification problems, evaluated just GPT out of the box on it and on the evaluation data, and then trained on different portions of the data to see like how many examples do we need to beat that accuracy. And it's maybe we can link the slide in the show notes. Like we've been meaning to publish this properly, but we haven't, because there's so much other stuff. But basically, for simple problems like news text or even sentiment, out of the box accuracy is really pretty good and quite impressive. But even with a few percent of the data, you can beat that. And so you just need, with some labeled examples, you can still exceed that. And especially on like harder problems like banking, you can really see that, well, out of the box, still impressive accuracy, given that, it wasn't trained to do this at all, but, it can very easily beat that. And even if you take that position that, hey, these models are going to get even bigger and even better and even more efficient, it's like, well, but at the same time also, so do the other techniques we can use to, always take it one step further. And there's clearly this advantage in, transfer learning by example, that, we can exploit in order to build something even better and smaller. And that's the kind of stuff I find exciting, or more exciting than how can we, replace everything with ChatGPT.
Yeah, absolutely. You brought up so many great points. I would encourage listeners to listen to two of your talks, large language models from prototype to production, and incorporating LLMs into practical NLP. The idea of using generative models, not necessarily for your solution in production, but using generative models and in context learning to help you gain labeled data to then fine tune models that you have control of. And I think we share that.
It also resonates with people. Like I've always, at conferences, I do talk to developers, and it generally makes sense. It's not just me going on stage and saying some crazy stuff. And similarly, also companies we talk to and work with, not for all use cases. And there are lots of new things that, of course, the generative capabilities add. And there's a whole other areas like chatbots that we're not really invested in or working much in. But they're definitely, I think, a lot of use cases where that sort of workflow really resonates.
Yeah, absolutely. I mean, for me, it's about having control. Not that I need to have control over everything, but it's about having control. It's about having the control over your model. The server being down isn't going to stop you from making predictions, right? That doesn't cut it for your clients. And in actuality, I mean, companies just want you to solve their business problem. They don't necessarily care the algorithm behind it that does it. So if you're able to create a way of extracting information in a way that provides them whatever the actionable insights that they're looking for, then you can, get closer to your goal. And that's a lot of the problems that I deal with, these predictive problems of extracting information, bringing structure to this unstructured text, which is a lot of, NLP. And yeah, all of the generative side of things, it's different, and it has different use cases. For my work, it's helped me build up data sets, and it's helped me validate my predictions sometimes. Like I kind of try to use it, in the loop, which I know is something that Prodigy is having LLMs in the loop, which is exciting and amazing to be able to use the newest things. So it's incredible what's going on in the field. And I want to zoom out to learning from machine learning. Welcome, that's where we are. I have a couple of questions in this vein. So who are the people in the machine learning field that influence you?
Yeah, so I don't want to, go I think a classic answer to this would be to rattle off like some, big names or people, on the internet. But I actually think even in my, my day-to-day life, or, what inspires or influences me in the work I'm doing is actually seeing a lot of the use cases or people who come in from like, really specific domain that they know a lot about, and then seeing them like pick up the tools and build something. And often, again, we already talked about like some interesting use cases of like SpaCy or like Prodigy with like cows and horses, but there are also so many other like areas and domains that like I know nothing about. And then, there's so many people who like, really have like this deep understanding and come in with a problem and succeed at solving it because, they pick up the tools, they're really doing it for a purpose. And I feel like these things keep coming up, and people, I keep, meeting and talking to people who, kind of came into the field that way. And I think it definitely also shapes how I think about the tools I'm building and the work I'm doing.
Very cool. Yeah, I mean, there will never be like problems aren't going to go away, right? People are just going to want to apply it to different areas. And one of the interesting branches of NLP is applying a lot of the cutting edge research and things that are done a lot on like English language and applying it to other languages where there's not, I don't know what on Hugging Face, there's probably tens of thousands, if not more data, English data sets. So having tools in your toolbox like SpaCy and Prodigy and being able to apply it to other languages, that's a really interesting use case, and it makes you think about things in a different way. So continuing learning from machine learning, I'm not going to ask general advice, but what advice would you give yourself when you were starting out in your career, or maybe when you were starting Explosion?
I mean, you get like, you can kind of take it full circle. It's like, would I have listened to my own advice at the time? Would I even give myself advice? But I don't know. I mean, it's difficult because, you always have the, kind of hindsight bias and survivorship bias. And there are like just a lot of these kind of biases that, make you interpret things that went well or didn't go so well, and I don't know, draw conclusions from it. So I don't know, it could be that like, hey, my, whatever I concluded is like really bad advice. But I do think there is some element of, I don't know, trusting my instincts or trust your instincts more and like, really do that because, but it's also difficult because, you don't want to, if you're doing things that are opinionated or a bit like different, and you have these ideas that like make total sense to you and are like super reasonable, and I'm like, of course should do it that way. You also don't want to lose sight of other things you might be missing, and you want to be open to suggestions, or you want to be open especially in later stages of your company to think about like, oh, here's how this is normally done. Maybe maybe you don't want to be stubborn because that can also have, bad outcomes. But I definitely feel like there were, situations where, it would have helped, like, my instincts were there and it was all reasonable and logical, and it's easy, I let myself get carried away, trying out something else and trying to be, open to the way of doing whatever it was that we were facing. And
right,
even though it didn't make sense, and the outcome was that, yeah, well, what did you expect? It didn't make sense.
right. I mean, yeah, hindsight is 2020, right?
Yeah.
And yeah, it's interesting. Well, two things, like when you're working on something, first off, like how involved you're in it. And sometimes like you put these blinders on, and then maybe like you might ignore some of the other factors that are happening. But that's
and I don't know everything. I mean, it's like I was still relatively young when we started the company. It's, the first time I founded a company, and yes, I've had like jobs before, I've freelanced before, but like this is, not something I've done before, and I'm operating off what's reasonable and what's logical, and drawing conclusions, and then also making decisions. Like if you're thinking about what product should I build, or what feature is it that people need, like you have to make a decision and you have to be right. And then you kind of, check your track record. And if you're mostly right, that's good. And you want to be right most of the time and not wrong. And if you're always wrong, that's bad. But, that's not really, again, that's also something you can't really, that's not, a playbook to operate by. It's like, be less wrong, be more right.
Right.
But that's ultimately what it comes down to.
Yeah, that works, but it's like there's no formula for doing that. And
no, exactly. And I feel like in terms of like looking at, where's the market going, and how are things developing, how's technology developing, our track record's pretty good. Like we've always, things have developed the way we predicted they would develop. I mean, not because, we have like these amazing, prediction abilities, but more because, hey, it all made sense, right? It's logical. And so we're like, okay, we feel pretty good on that. Then there are lots of other areas of like, how do you do a thing? How do you, scale up things that previously worked well? How do you, grow a team, grow the right team, decide what to focus on, and those are all things that are hard. And I think, again, there's no playbook. Like every time we deviate from something and do what feels right and makes sense, it usually makes sense, and it is usually the most logical next step. It's all a bit abstract or philosophical, but that's basically
it makes a lot of sense. I mean, trusting your gut, trusting your instincts, thinking logically about things. Sometimes you just know, like deep down inside, maybe you don't have like the data to show it, but you just kind of, you know like what it's going to be.
Yeah, like I actually, this is my reminder. I don't know, it's mirrored, but yeah. Oh, and
a logic and reason, a logic tattoo, and reason.
I see that when I
there you go.
When I type.
Yeah, that's awesome. I mean, a reminder of logic and reason, it'll get a lot of people a long way. I'm gonna flip the last question, and I'm gonna say, what's one piece of advice that you've received that stuck with you, either for your startup or just your career in general?
Yeah, I think, I don't know if it's like, advice I specifically received, but like to go back a bit, like before I, went into tech and really, started my career, I was kind of, I didn't really know what to do with myself. And I was young and like, living on my own. And I got really into like self-help kind of stuff. And, it's all a bit cringy, if you think about it. And, it's definitely, I think it was always weird, but when I really caught on and was like, this is really bullshit, like, the kind of the secret-esque like stuff, it's like, I just refuse to, believe in the universe. Like that's kind of where it like stopped. There are a lot of things where you can be like, oh, psychology and I guess blah blah blah, but then if it's like when it came to the universe, I was like, well, no, like the universe is not gonna, I don't know, reward me with whatever I'm manifesting and that kind of bullshit. Like yeah. So and you know, I think I also wrote about this on my blog, and I kind of got to this point where I was like, okay, no, I just need to kind of get my shit together and like take responsibility for my life and you know, this whole like, you know, follow your dreams type thing and manifest stuff that's like, you know, that's not working. And that kind of also led me to reading more like I don't know, more kind of career or business minded things that had never appealed to me before. Like you know, I never really saw myself as like wanting to have a career, or like it just, a lot of these things like would have felt really wrong to me before that. But after going through this whole like you know, shift after refusing to believe in the universe, that really, I don't know, I think it woke up my entrepreneurial spirit, or like really also that like, hey, things can be pretty simple. Like you can, I mean, it's not like nothing is easy, but like, hey, if there is something you can create that like people can pay some money for, you can live off that. And like, okay, you just have to, you know, you can have these ideas and you can actually do these things. And you know, you can, if it's something you enjoy, you can actually, you know, you don't have, it just, you know, you don't have to like force yourself to like work, but like it actually makes sense if you're like passionate about it. Yes, you can work more and more and more, and then maybe at some point in the future I can, you know, take some time off when I'm like sick of it and need a break. And there's a lot of this sort of, you know, mindset that I discovered through that whole experience of like not really knowing what to do with myself. And I do think that has definitely influenced me a lot. You know, when we started the company and now we're actually like, running a business.
I think that's great. Thank you for sharing that. I can definitely relate. I think that I'm not sure if everyone goes through it or experiences it, but like there comes a time when you sort of realize like no one's going to do it for you, right? Like you're the one, this is your life, and kind of just taking responsibility for your actions. And then if you're lucky, or maybe luck's not the word, but to find something internal that can kind of like, you know, drive you, which, you know, something, I mean, this type of work that we're doing is fascinating. I mean, I find natural language processing, machine learning fascinating. I was willing to create a podcast about it.
No, and I think there's also, you know, that then ties into that's also, you know, of course we're also very you know, privileged, or like, you know, I certainly am, or being in this industry, it's like you know, of course, like things, you know, the world is not fair, and it's like we happen to be working in this industry where like what we are doing is very valuable, and you know, often in ways that are like you know, a pretty stark contrast to other things. And you know, and also other parts of like every individual story. Like in my case, yes, I was able to don't take some more risks because I was young, I don't have any dependents, and even now, I'm like, you know, I have, you know, different options than other people, and you know, then other people are like advantaged in other ways. So, you know, for example, my co-founder Matt, he also makes sure to always point out, hey, when he started SpaCy, he got an inheritance from like a small inheritance, but it allowed him to take some time off and really focus on writing an open source library, because like that is not like, you know, something people can just do. Like, you know, you need to be able to live somehow. And, you know, I didn't really go down this nerdy path of saying like, oh, I implement this library that kind of doesn't really exist yet from scratch. And I implement it in Python, which is this, you know, even back then, even more like somewhat more obscure language that compiles, that looks like Python and compiles to C extensions. and I start with the data structures. That's like, true story. And
Right.
but they're still super stable. Like, it was worth it. But it's still, again, like doing, I really, and again, I think maybe also comes from like my, disdain for like the self-help narratives, but like, I really don't want any of these things to be turned into this aspirational story of like, oh, quit your job and write an open source library. And it's like, yes, you can do that, but there are a lot of circumstances that go into that.
Yeah, I mean, it makes a lot of sense. The unfortunate reality, everyone doesn't have the same opportunities and resources. Yeah. But I mean, it's important to make the most of those things and to make the most of those opportunities. So yeah, there's something to it. And I mean, we've been touching on it. But the last, really, really good one. What is a career in machine learning and software taught you about life?
Yeah, I mean, we were almost.
I know,
like there,
we kind of
right?
did it.
Like,
we did it already, but I have to ask it.
Thinking that also, yeah, I mean, also with like, so many things going on, good or bad. Like, I don't want this to sound too depressing, but it's like, well, life is hard and the world is kind of, hard and unfair. And, with privilege also comes responsibility. But at the same time, it's also good, to be able to create something that's valuable and like, do things that are like not terrible and not again, I think that's like, sorry for ending your podcast on like this
do things that are really not terrible. No, it's fine.
This really negative, really downer note, but yeah.
No, it's all good. There's so many things that we were able to go into and unpack. There's going to be tons of great things for listeners. So no worries. Ines, it's been such a pleasure. If somebody wants to learn more about Explosion or your work, where would you lead them?
Well, our website, explosion.ai, or my website, which is ines.io. And yeah, we can put that in the show notes. That's kind of where we collect all the things. You could find us on various social media, on GitHub. You can, check out our projects, whatever you're interested in.
Awesome.
Oh, and of course, like conferences, like check out our events page, which is on our website, which is where we list upcoming events like PyData New York City, for example. Yes. That I don't know if I'll see you there.
I will see you there. Yes.
Yeah, but conferences like that and talks that are upcoming, because it's really nice to also meet people in person again. Yeah,
that's great, Ines. I really appreciate the time. Thank you for answering my questions, letting me pick your brain, and really thank you for all of the great work that you're doing with Explosion. It's much appreciated. Thank you so much.
Yeah, thanks again for having me. This was a lot of fun.
Thank you for listening to this episode of Learning from Machine Learning with the inspiring Ines Montani, co-founder and CEO of Explosion, the company behind SpaCy. Ines shared so many fascinating insights into machine learning, open source development, and building a successful company in this emerging field. Don't miss out on the resources in the show notes. If you enjoyed this chat, don't forget to subscribe and share with friends and colleagues. Thanks for listening, and until next time, keep on learning.